Hello and welcome to another episode of LiviusTV. I'm your host, Jason Brenkoff. And today I've got one of my favorite topics to talk about because it is one of the most frustrating topics for parents and students alike. And that is the myth of new math. In fact, this myth is so prevalent, it's actually even reached into the most popular of popular culture. Take a look at this clip from a movie you may have seen called The Incredibles 2.
We will control the horizontal. We will control the vertical. We can roll the image.
That's not the way you're supposed to do it, Dad. They want us to do it this
I don't
way.
know that way. Why would they change math? Math is
it's
math.
okay,
Math
Dad.
is math.
I'll just wait for Mom to get back.
What? Well, she won't understand it any better than I do.
Wow. I mean, if this can frustrate Mr. Incredible, one of the most incredible superheroes in all of superhero history, I can imagine us normal folk being equally frustrated. But the good news is that new math is just a myth. There is no such thing as new math. To Mr. Incredible's point, math is just math. Let me show you what I mean. So a lot of us back in the day learned how to do certain basic skills like multiplication in a very particular way. So you might see up on the screen next to me a multiplication problem. 357 times 42, right? That's a 3x2 digit multiplication problem, something that most late elementary, early middle school students should be able to handle pretty easily. And the way we would do it back in the day is this method. You write it out just like this, 357 times 42. And then starting with the 2, you multiply each of the numbers in the 3-digit number above, writing them below, and doing this crazy thing called carrying. So if we notice that 2 times 7, for example, is 14, you put the 4 beneath the 2, and you put this little tiny 1 above the 5. And then you follow through with 2 times 5, and you add that 1, and now you write, instead of 2 times 5 is 10, you write 11. 1 below the 4 and 1 above the 3. If you're already confused, now you can see why elementary school students are confused with this methodology. But this is the way we learned how to do multiplication back in the day. If you follow through the problem, then you continue. 2 times 3 is 6. You add 1 and you get 7. So now we see beneath the line 7, 1, 4. And then we go to the next level. 4 times 357, and you can't just start though, you have to block out a space. I usually put a 0 with an X through it. You might have been taught to put an X, you might have been taught to put a 0, but you have to block out that space. 4 times 7 is 28. We put the 8 beneath the 1, because that's directly beneath the 4. It's confusing, isn't it? You carry the 2, we've already crossed out the 1 and the 1, or if we haven't, we should do it now. No wonder kids are confused. The 2's up there. 4 times 5 is 20. You have to remember to add the 2 back in, so now it's 22, and put that 2 there below the 7, and then the 2 above the crossed out 1 above the 3, and 4 times 3 is 12, plus 2 is 14, and that goes over there, and now you have 1, 4, 2, 8 in that second line. Now you draw another line under that, and you add them together, and you get the answer, 14,994, and gosh, I'm exhausted. Right? And that explains why teachers don't teach it that way anymore. The math is going to be the same, but the methodology is more logical for today's students. So let's start all over again. Let's erase all that. 357 times 42. So we're going to start with that 2, and we're going to multiply the 2 times each value in 357. Not each digit like we just did, each value. So students these days start with 2 times 7. And there's 14. Then they do 2 times 50, because remember, it's 357. And 2 times 50 is 100. And notice how we're stacking it up. Now, 2 times 300. Because remember, it's not a 3, it's 357. So 2 times 300 is 600. And then we go to the next place. And that's not a 4. Remember, the number's 42, it's a 40. So 40 times 7 gets us 280. The next one is 40 times 50. And again, there's a cool shortcut you can do with these nice round numbers. You just count up the number of zeros. You start out 0, 0, and then it's 4 times 5. Then you put a 20 in front of that, and now you get 2,000. So students can use these simple shortcuts using this methodology that weren't available to them with the crazy carrying method that we just did. And lastly, 40 times 300, which gets us 0, 0, 0, and 4 times 3 is 12, 12,000. And now you add them straight down. 14, 100, 600, 280, 2,000, and 12,000. We add them all up, and lo and behold, you get the exact same number, 14,994. Here's the deal. There aren't fewer steps, but each step is simpler. It's less confusing to students. There's none of this crazy carrying and remembering places and all that sort of stuff. So this is what the new math is. In essence, it's the same math, but just a slightly different method for doing it that makes more sense to students and avoids confusion. Will students learn it the classic way? I can say this for certain. I have students who are in 3rd, 4th, 5th grade, 6th grade. They learned long division the new math way, and then they went back and learned it the old math way, but they had a better understanding of it, and it made learning the old math way simpler. So if you're confused about the new math, don't worry. It's the same math. Just instead of taking one route, you're taking a slightly different route to get to the same result. Please, I know this is going to cause confusion and questions. Put those questions, put those comments below in whether you're watching this on Facebook or Google or some other platform like LinkedIn, etc. Ask us those questions and we will respond to you. We'll answer questions. If you do like this video, please remember to star, fave, heart, thumb up, whatever the format you're using to watch this video lets you do, and hit that share sheet. Share this video because I know this is going to be a topic where a lot of people are confused. Share it out there to your friends, families, coworkers, colleagues, etc. Thank you so much for watching, and as always, let's keep learning.